Hi everyone, welcome once more to this YouTube channel, Best Science Brain YouTube channel. Today we are taking a look at WAEC 2024 May June examination, and today we're going to look at titration or volumetric, otherwise known as quantitative analysis. And in this May June examination, we are going to look at we're given A, and A is 1.56 gram per dn cube, 1.58 gram per dn cube of potassium per manganate, while B, which is iron sulfate, 5.5 gram of iron 2 sulfate. So this reaction is a redox reaction we are going to perform. And the aim of this tutorial or this lesson we have is to have an estimated endpoint for the reaction. And after that, we're going to run some calculations on some questions or speculated questions on for this May June WAEC 2024 examination. So stay connected to the channel. If you are not subscribed to the channel, please move up to the channel's name, Best Science Brain, as the video is playing. The channel's name comes under the video. You see a bell, a subscription bell, tiny bell. Tap on it only once and get subscribed to the channel. So WAEC is West African Examination Council, meant for students in SS3 or high school 3, people who are about graduating from secondary school. The certificate examination, which is more like the SSCE, Senior School Certificate Examination A level, or the London Cambridge GCE examination. So people are watching from far distance. So you can compare WAEC to school SAT or Cambridge examination, which is taken in UK or abroad. So run similar syllables. So today we're going to start with titration experiment. So now we'll start with question. So we have a speculated question for this year's 2024 May June WAEC examination. Number one says solution A contains 0.395 grams potassium permanganate per 250 cm cube. Solution B contains iron sulfate. Put A into the burette and measure 20 or 25 cm cube portions of B into a conical flask. Also add 10 cm cube of dilute H2SO4 into the portions of solution B in the conical flask. Titrate solution A against the mixture in the conical flask, that is solution B, until the pink or purple color of solution B persists. Repeat the experiment to obtain consistent titer readings and tabulate your readings. We come again. Solution A contains 0.395 grams KMNO4 per 250 cm cube. Solution B contains iron sulfate. Put A into the burette and measure 20 or 25 cm cube portions of B into a conical flask. Also add 10 cm cube of dilute H2SO4 into the portions of solution B in the conical flask. Titrate solution A against the mixture in the conical flask, solution B, until the pink or purple color of the solution B persists. Repeat the experiment to obtain consistent titer readings and tabulate readings. So we'll go over to the experiment. So this is solution B, the iron sulfate. We're going to measure out 25 cm cube. We'll use a measuring cylinder and measure out 25 cm cube from solution B collected in the beaker. So we'll pour it into the measuring cylinder to get 25 cm cube as given in the question. So let's see. 25 is at the midpoint, so it's still below 25. I add more of solution B, the iron sulfate solution, iron 2 sulfate. So we are approximately there. 25 cm cube. We'll now transfer this 25 cm cube of the iron sulfate into the conical, a neat conical flask. So that is it. And we're also asked to measure 10 cm cube of dilute H2O4 and add it to solution B. So we use a smaller measuring cylinder and then collect 10 cm cube of this acid. Is that three there? We pour it into the conical flask. So we have a mixture of solution B, 25 cm cube, and 10 cm cube of 10 of H2SO4. Okay, all right. So we're about to start the titration now. We'll have the solution A, potassium permanganate in the burette leveled up to 0. Then we'll have the solution B with the H2SO4 inside it in the conical flask. So start titrating to know when the color will change. So as you add the chemical, you shake the flask. And you're going drop by drop. You cannot, for now, you cannot say where the color will change. So you go drop by drop. Taking it one drop at a time. The white paper there is for us to have a good or sharp color change to ensure after the white tie to ensure accuracy in the experiment. So until the pink color or purple color persists, that one you have the end point. So we'll see moving. Take it drop by drop. We're getting to the point. You see, it has changed. We add one more drop. It's somehow brownish. We add one more drop. That's okay. You see, that's the end point. So let's go up. This is 3.1, 3.2, around 3.30. Now we start from 0 and the color change around 3 is a quick endpoint. 0 to 3.30. So the final read is 3.30. Initial is 0.00. These are rough. So we'll go to the board and report our work. The board will have the format to report our work. The volume of B is 25.00. That B is the iron 2 sulfate solution. You don't add the volume of the acid to it. You don't add the 10 cm cube to it. From the B measured is 25.00 cm cube. And then for the first one we did now, the initial started from 0.00. Final was the color change at 3.30. Record your values to 2 decimal places. Then subtract, you have 3.30 as your titer value for the rough. So we'll now go to the first experiment. So we are starting the first titration now, having done the rough. We still have enough permanganate in the burette. So we're starting around 3.34 as the initial reading. I will titrate into the acidified iron 2 sulfate. So we'll start this one again and see what will happen. Will be increase our speed a little, maybe adding two drops. Now, since I have an idea of where the color change initially, so we expect this one to change in the next 3.33. That's the next 3.33 will be around 6.7. So it'll be faster in this case. But we'll not reach 6.7. We'll reach 6. We'll take it step by drop by drop. So we look at it, we are around 5 point something now. So let's see what's going to happen. So maintain consistency and accuracy. Readings should be very close to each other. Okay, we are past 6 a little. So view it, this is 6.1 or about that. 6.1. So we're going to take it easy now. Drop by drop until the color changes. Our focus will be on the burette. I think it's about changing. You see, almost there. We need one drop. That's okay. That change. So change. We'll have about 7 here. So about 7, 6.57 is okay. So the initial reading here is 3.40 where we started from, and the color change around 7.00. So subtract 7 minus 3.40, please. 3.60. So we'll still try the second one and the third one and see what to select for our titrate, for our average titer. So that is it. Ready? So we are now starting the second titration as 7. That's the initial reading now. And then we'll start titrating. To be faster now. Get in there. Color is almost changed. One more drop. Add the pink color. That okay? That should be okay. Okay. One more. That's okay. That's okay. Okay. So now where I see that should be 10.50. Then from 7, color change at 10.5 estimated. Then you subtract, what do you have? 3.50. Okay? So you see that these two are green. That one is off. So we can still do a third one to confirm our answer. We're now doing the third titration. We're starting from 11. Initial reading 11. And then we're going to run the permanganate into the acidified iron sulfate. It's almost changing. I change. So we are 14.5. You can see it. 14.5. That's what they call a change. 14.5. Where did we start this one from? 11.00. Change at what? 0.50. Take the difference. What do we have? 3.50. So having done that, we can find our average theta. So that is question 1A from the question booklet and the question we have for this tutorial. So our 1A, it says find the average one of AUs. We ignore the rough. The rough is somehow far from the these ones. You want to take your average theta, the readings you should take should not differ by plus or minus 0.20 cm. Difference between this and that is zero point 0.1. These two are equal. 0.1 difference. But difference between this and that is 0.3. So the rough is off. So we're going to select 1, 2, and 3. So our 1A, our VA now becomes 1 plus 2 plus the third theta all over 3, or in cm cube. So having done that, we now move up and say VA equal to the value for your, this one is 3.60, second theta 3.50, third theta 3.50 over what? 3, or in cm cube. So what do you have as your value when you divide? 3.533. So have 3.5 to two decimal places, 53 as the estimated end point for this 2024 WAEC examination. 3.53. So the mistake we make sometimes as teachers is to assume that the end point is what you get by calculation. So basically, when you calculate it, if you calculate this endpoint, you're getting 18.10, 18.1, and 18.2. And it may go like that if it's an acid-based titration. But because the redox reaction, you may not get the endpoint you feel you're going to have when you do it by calculation. So when you give students wrong endpoint, the enter exam or the question gives a different thing altogether. And perhaps with that wrong endpoint, they'll be getting negative answers when they're calculating. So WAEC knows where the endpoint should lie. So if you do estimate a wrong endpoint by calculation, you're a lazy teacher, you don't want to go to the lab and do titration experiments, you just go and calculate and give to students. Students will go with a wrong endpoint. So this is 3.53. The endpoint will be within the range of 3.5, 3.51, 3.52, and 3.53. So for experiment, we're getting 3.53. So now we're going to look at some questions that are expected from this kind of experiment. So stay connected as we continue. Go to question 1B that says, from your result and information provided, calculate the I concentration of A in mole per dn cube. BI, we're out to find the concentration of A in mole per dn cube. So let's go to the main question and see read it again. Solution A contains 0.395 gram of potassium permanganate per 250 cm cube. So we are given the mass of A in 250 cm cube, which is 0.395 gram. And then solution B contains iron sulfate. So the mass of solution B, we don't know anything about solution B. There's no concentration of solution B given to us. So A is what they gave us the mass, 0.395 per dn cube. And we have to find the concentration of A in mole per dn cube. So go to question BI. So from the question, we have this information that A contains 0.395 gram per 250 cm cube. So all we have to do is to find the mass of A in 1 dn cube, which is called the mass concentration. So we now say 250 cm cube of solution contains 0.395 gram of A. Therefore, 1,000 cm cube, which is 1 dn cube, of the solution will now contain 1000 cm cube multiplied by 0.395 gram divided by what? 250. And that'll give you what? 1.58 gram per dn cube. So this is the concentration of A in gram per dn cube. Then you find the molar mass of A. The molar mass of A is potassium manganate. Using the atomic given to you in bracket. Potassium is 39, manganese is 55, oxygen is 16 multiplied by 4. When molar mass will give you 158 gram per mole. Make sure you specify these values in 3SF. So looking for Ca. Ca becomes concentration of A in gram per dn cube, which is written as rho or Pa over molar mass. So the conc of A gram per dn is 1.58, which we got here. Molar mass 158. When we divide, we're going to get 0.010. It has another 0 to 3SF mole per dn cube. Check out. Whenever we say equal to in calculation, the value must be presented in 3SF, 3 significant figures. Look at the values here, all in 3SF, all in 3SF. So this is our Ca, the conc of A in mole per dn cube. So go to question BII that says concentration of B in mole per dn cube. We have to calculate the concentration of B in mole per dn cube. Remember that your B is iron 2 sulfate solution. That's your B. So on the board, we have the equation for the reaction given to us on the white paper. This is the equation in terms of ionic equation. This represents our A, potassium permanganate. Represent the iron 2 sulfate. What represent the H2SO4 that is added to the iron 2 sulfate. So our Cb is what we're looking for. Our Ca is obtained from question BI, which we saw a few minutes ago, 0.01. Our Va, the average titer, 3.53, which we got for the experiment. Our Na, there's 1 mole of the permanganate. Mb, 5 moles of the iron 2. So in this Na and Mb, we don't use the hydrogen ion. We use the chemical, the reagent, the manganate and the B, which is the iron sulfate. Vb is one of the bases we measure to 5 cm cube. So since we know Ca, we don't know Cb. We use the general titration formula that says CaVa all over CbVb equal to Na over Mb. We'll go ahead and make Cb the subject of the formula. Cb becomes equal to CaVa multiplied by Mb all over Vb times Na. We now make your substitutions. The value of your Ca is 0.01. Your Va is 3.53. Your Mb is 5 all over. Our Vb is 25. Our Na is 1. Please help us with the value. Give a value in ordinary number, not a standard form. 7 what? Speak out. 0.007 what? What following the 6? Nothing. So values, answers should be given to 3SF. 1, 2, and 3. So 0.00706 mole per dn cube. So that is the concentration of B in mole per dn cube. That is answer to question BII. We now go to question 1B triple I that says amount in moles of B. We should calculate amount in moles of B into 5 cm cube of solution B. Amount in moles of B into 5 Cn cube of solution B. So we're going to question 1B triple I. Looking for the, we're looking for the amount in moles of the base, not the base this time around, the iron 2 sulfate into 5 Cn cube of the solution. Remember, the 5 Cn cube represent the volume of the base used, of B used, sorry. So now we're going to apply this formula to find the amount in mole. Use CV over 1000. But this time around, your C becomes CB, that's the equation of B, and V becomes VB, the 5 Cn cube you're asked in the equation. If you have to find the amount in mole of B in 250 Cn cube, you use the same CB because it's B, and then use V now as 250. But the question says 25. That was using V as 25. You know in more that you must use VB as 25 to find the amount in mole. Since the equation specifies 25 Cn cubes, that means the volume you use the volume of the base. So we'll make our substitution. Make our substitution here. Our CB is 0.00706. Then times 25 over 1000. So please hurry up and give me the answer. 0.00 and triple zero. Yes. 17 what? 1765 mole. But I say leave your answer to 3SF. So that's going to be 0.00. You start from the non-zero digit to count the important figures. 1, 2, 3. That is 177 mole. So we'll start with 1B IV that says we should find the concentration of B in gram per dn cube. The concentration of B in gram per dn cube. So we're looking for the concentration of B in gram per dn cube. We're going to apply this formula. Concentration in mole per dn cube CB equal to mass conc, which is rho B or PB over molar mass. Make PB the subject. So PB becomes equal to CB times molar mass by cross multiplication. And we're getting CB already as 0.00706. Of that what we got? Mole per dn cube. We now find the molar mass of B. B is, of course, iron sulfur, FeSO4. That becomes iron is 56, sulfur 32, oxygen 16 multiplied by 4. When you solve this, you get 152 grams per mole. So having done that, now find your rho B, which is going to be 0.0, making substitution in this formula, 0.0076706 times 152. And that become the concentration of B in gram per dn cube. So work out this, please. 0.00706 times 152. One point what? 1.07 what? 312. So we're going to for 3SF. So 1.07 gram per dm cube. That is the answer. We now move over to question 1BV that says calculate the number of manganese 2 ions present in 250 Cn cube solution. Number of manganese 2 ions present in 250 Cn cube solution. To solve 1BV, which is the number of manganese 2 ion, which is a product present in 250 Cn cube of 250 Cn cube solution. So we're going to work from the balance equation. We'll connect the manganese ion to the manganese 2 ion. You see that 1 mole of this gave us 1 mole of that. Now write 1 mole of the manganese 7 ion produce 1 mole of manganese 2 ion. Having done that, we now look at the concentration of this substance. The Ca is 0.01 mole of manganese, manganese 7 ion. We also produce the same 0.01 mole of manganese 2 ion. So that is the conc of manganese 2 ion is 0.01. The ratio is 1:1. So the concentration of manganese 2 ion is 0.010 mole per dn cube, because this is the number of moles in 1 dn cube. But the question is talking about 250 cn cube. So what do? We have to find the number of moles. This is the number of moles of manganese 2 ion in 1 dn cube. Find the number of moles of this ion in 250 cn cube. We use mole equal to CV over 1000 to find the number of moles of this manganese 2 ion in 250. We then convert the 0.010 times 250 over 1000. So what do you have when you solve this? Someone else should try it and get the right answer. 0.00. So we have 0.0025. Put another zero at the back to make it 3SF. So this is not the answer. We're not looking for number of moles. We're looking for number of ions. Having we have to find number of moles, we have stopped there. Number of ions begin by number of moles times Avogadro's constant, which is given to us. And that will give the 0.00250 times 6.02 times power 23. So what the answer? 1.505. 3SF is what? 1.51. Times power what? 21 ions.